Hi students, so welcome you all for application of derivatives chapter. So in that first we are going to solve the problems on increasing and decreasing. Okay, so as you all know, the increasing and decreasing concept in the application of derivatives is very important. So let us go through this chapter and let us take some of the previous year questions and also some of the important questions on the increasing and decreasing functions, and let us also learn the logics of increasing and decreasing function. Okay, so I'll start with the problem number 1. That is, here it is given as f of x equal to, here it is given as f of x equal to square root of a square minus x square is increasing on option 1 minus infinity comma 0, option 2 minus infinity comma plus infinity, and option 3 minus a comma 0, and option 4 minus a comma plus a. Okay, so no problem. So first here we have to check the derivative of the given function. The derivative of the given function. So as you all know, f of x is root of a square minus x square. So f dash of x is going to be equal to minus 2x divided by 2 times of root of a square minus x square. So here 2 and 2 will get cancelled. Minus x divided by root of a square minus x square. Okay, so here root of a square minus x square is always positive, and see, if f dash of x has to be positive, if f dash of x has to be greater than 0, means x has to be negative. X has to be negative. Okay, so therefore if x is negative, negative into negative will become what? Positive. So therefore f dash of x will be greater than 0 if x is lesser than 0, and f dash of exist if a square minus x square is greater than 0. So here x should be lesser than 0, and it should satisfy a square minus x square greater than 0. That means you have two equations. One is x is lesser than 0, and another one is a square minus x square is greater than 0. Okay, so by taking x is lesser than 0 and a square minus x square greater than 0, you can just see by solving this. Now x is going to be greater than minus a and lesser than plus a. So therefore x is lesser than 0 and x is in between minus a and plus a. So therefore you can just see by taking intersection of these two, you can just tell that x must be greater than minus a and lesser than 0. Okay, so here from this you can just see x belongs to minus a to plus a, x belongs to minus a to plus a, and from the first equation we know that x belongs to minus a comma 0. Okay, so therefore by taking these two equations, by taking these two equations, you can tell x belongs to minus a comma 0. X belongs to minus a comma 0. That is option 3. Okay, so here the very important thing is you have to differentiate the given function. You have to differentiate the given function. After the differentiation, you can just see it will be minus 2x divided by 2 times of root of a square minus x square. You can cancel 2 and 2. So once if you cancel 2 and 2, it will remain with minus x divided by root of a square minus x square greater than 0. So here you have two functions. One is minus x, another one is root of a square minus x square. So here you can just see minus x. In this minus x, x should be negative, and here a square minus x square should be greater than 0. Okay, so you have to take these two equations. One is x lesser than 0, another one is x a square minus x square is greater than 0. So by taking those two terms, you can just see from this we can say x belongs to minus a comma plus a, and from this and these two equations you can just tell x belongs to minus a comma 0. Okay, so therefore f of x is increasing at open interval minus a comma 0. Clear? Okay. Now we shall see the second problem, that is if f of x equal to a sin x plus b cos x divided by c sin x plus d cos x is an increasing function, then a by c must be equal to b by d, bc minus AD must be greater than 0, AD minus BC must be greater than 0, AD plus BC must be greater than 0. So this is a straightforward problem from the result that AD minus BC must be greater than 0. See that A multiplied with D and B multiplied with C. Therefore AD minus BC, AD minus BC must be greater than 0. AD minus BC must be greater than 0. Okay. So from this, now you can just take this as a formula. Therefore, option number 3 will be your result. So please remember this very important technique. That is, if the function is given in this form, AD minus BC should be always greater than 0. Okay. So now from this we can go for the next problem, that is if the function cos x plus k sin x divided by 2 cos x plus 3 sin x is decreasing for every x belongs to R, then k belongs to what they are asking. They are asking the value of k. Okay. So now this is 3 by 2 comma infinity, 0 comma 3 by 2, minus infinity comma 3 by 2, minus infinity comma 0. So here my dear students, already we know one formula, that is 1 into 3, 3 minus 2 into k, 2k. Decreasing means must be lesser than 0. But according to this problem, if I differentiate the given function, you just see by differentiating the given function you are going to get minus cosecant square x divided by 2 cot x plus 3 whole square lesser than 0. Okay. So here have some patience, don't make urgent because already you know the result, but have some patience. Take sin x common. If you take sin x common, what happens? If I take sin x common, it will be cos x by sin x, that is cot x, plus k divided by, here also you can take sin x common. So if I take sin x common, it will be 2 cot x plus 3. So therefore sin x you can get cancelled. So therefore you will remain with cot x plus k divided by 2 cot x plus 3. So now if I differentiate this function, you are going to get 3 minus 2k minus cosecant square x divided by 2 cot x plus 3 whole square. 2 cot x plus 3 whole square. Okay. So you just see you have minus sign here, you multiply for this. So that will be minus of 3 2k into cosecant square x divided by 2 cot x plus 3 whole square. You can multiply for this. So therefore it is going to be 0. So now if I make this as positive, it will be 3 minus 2k greater than 0. Okay. Therefore 3 minus 2k will be greater than 0. If you simplify this, you can just see 3 will be greater than 2k and k is lesser than 3 by 2. K is lesser than 3 by 2. So if this is 3 by 2 and if this is lesser, it is going to negative infinity. Okay. So if k value is lesser than 3 by 2, it is going to negative infinity. So therefore k belongs to minus infinity comma 3 by 2. Minus infinity comma 3 by 2. Clear? So that you can just see option 3. Option 3 will be the right answer. Option 3 will be the right answer. Clear? So here if you want some more clarification about this problem, you just see option 3 will be the right answer. Okay, that's why be careful. Once you just take f dash of x, once you take f dash of x, then it is going to be very simple. Okay, so here f dash of x is 3 minus 2k into minus cosecant square x divided by 2 cot x plus 3 whole square lesser than 0. So therefore you just see this is negative function. If it is negative function, as we all know that to make it as positive, the sign will change its nature. So 3 minus 2k will be greater than 0. Therefore k will belongs to minus infinity comma 3 by 2. That is option 3. Okay. So very quickly now we can move to the problem number 4. Okay, so we can move to problem number 4. That is f of x equal to root 3 sin x minus cos x minus 2ax plus b decreases for all real values of x. Then decreases for all real value of x. Then which of the following is true? A is lesser than 1, A is greater than 1, A is lesser than 1 by 2, A is greater than 1 by 2. Okay. So now you can just differentiate the given function. You can just differentiate the given function and you can understand the problem. Okay. So for that what we shall do? You take f of x and you differentiate it. You take f of x and you differentiate it. You will get differentiation of sin x as cos x, differentiation of cos x as minus sin x, minus into minus will be plus sin x, differentiation of minus 2ax will be minus 2a, differentiation of b is 0. Okay, so this is our f dash of x. Clear? So as we all know, f dash of x must be greater than 0. So therefore let us take f dash of x is greater than 0 and let us simplify it. Okay, if I simplify, we get 2a greater than root 3 cos x plus sin x. Clear? So now by getting this type of equation, you must understand that here 2a must be lesser than maximum of this to decrease, greater than maximum of this to increase. Okay, therefore you just see 2a is greater than maximum of root 3 cos x plus sin x. So whenever the equation is in this form, a sin x plus b cos x, the maximum of this term will be a square plus b square. Okay, so that you must know. So now here you can understand one thing, that is 2a must be greater than maximum of root 3 cos x plus sin x. So it should be greater than maximum, 2a must be greater than maximum of root 3 cos x plus sin x means 2a must be greater than root 4, that is nothing but 2. Okay, so now a must be greater than 1. So if a is greater than 1, the function is going to be decreasing. That is for your option 2. Clear? So my dear students, go through these problems and also understand the techniques very nicely so that you can go through all the problems and understand the techniques as well as the concepts for increasing and decreasing functions. Okay, so now here you can just see f of x is equal to log x divided by x is increasing in. Okay, so f of x is equal to log x by x is given, so it is increasing in which interval we have to find out. So for that you can just see we have f of x by q of x, sorry, f of x by g of x. Whenever we have rational function, you just differentiate it. By differentiating it, you can just see here f dash of x is 1 minus log x divided by x square. F dash of x is 1 minus log x divided by x square. You just differentiate it by u by v rule. Differentiation of u by v rule. Okay, so that is v into du by dx plus u into dv by dx divided by v square. So by doing this, you get 1 minus log x divided by x square. So now you are going to get 1 minus log x greater than 0. That will be 1 is greater than log x. So if I take log on this side, it will be e to the power of 1. That is greater than x. So therefore, e will be greater than x. If e is greater than x, then you can just see if this is e, x is lesser than e, that comes to negative infinity, minus infinity comma e. X belongs to minus infinity comma e. But here you can see the log x term doesn't work for negative terms. So therefore, the answer will be from 0 to e. The answer will be from 0 to e because it is not defined for the negative values. It's not defined for the negative values. Clear? Okay. So now the option 1 is going to be the right answer. Option 1 is going to be the right answer for the given particular function. Okay. Very good. So now quickly we can move for the sixth problem. That is, if f of x equal to sin x, if f of x equal to sin x minus cos x minus ax plus b decreases for all x belongs to r, decreases for all x belongs to r, then, okay, so see, you can differentiate this. If I differentiate it, it will be cos x, it will be plus sin x, it will be minus a. Just differentiate it, you will get cos x plus sin x minus a lesser than 0. So after that, you can just go through a solution of this. That is, decreases means f dash of x must be lesser than 0, or decreasing f dash of x must be lesser than 0. Therefore, cos x plus sin x, cos x plus sin x must be lesser than a, and hence you can just see for decreasing, as we have already solved, it should be greater than, a should be greater than maximum of cos x plus sin x. A should be greater than maximum of cos x plus sin x. So that will be root of 1 square plus 1 square, that is root 2. So a is greater than root 2. Therefore, for a is greater than root 2, this function is going to be decreasing. Therefore, this is our required answer. Okay, that is a is greater than root 2. Clear? Okay. So now from this we can move to the next problem as soon as possible, so that we can cover more number of problems. Okay, if x is greater than 0, then log of 1 plus x minus 2x divided by 1 plus x is decreasing, increasing, oscillating, none of this. Okay, they are asking for x is greater than 0. No problem. First, you just differentiate the given function. By differentiating the given function, you are going to get 1 by 1 plus x, 2 by 1 plus x whole square, that is equal to x minus 1 divided by 1 plus x whole square. As you all know, differentiation of log x is 1 by 1 plus x. And here you can see u by v rule. You just apply differentiation of u by v, so that it is going to be v into du by dx minus u into dv by dx divided by you can just say v square. Okay, by taking that, it will be v square. So therefore it will be equal to x minus 1 divided by 1 plus x whole square. So now we got f dash of x. So here you can just see this is always positive. It is always positive. And now you have to check for this. Just see for this what happens. Whenever x belongs to 0 to 1, whenever x belongs to 0 to 1, it is negative. Whenever x belongs to 0 to 1, that means x is lesser than 1, greater than 0. X is greater than 0, lesser than 1. So if x is lesser than 1, then it will be negative. Okay. So whenever x goes lesser than 0, whenever x goes lesser than 0, you can just see that it is going to be negative term. So whenever x becomes negative, this whole term becomes negative. Clear? So for that, you just see. Now, if x minus 1 divided by 1 plus x square is greater than 0, if x is greater than 1. So here it is lesser than 1. If x goes greater than 1, it will be positive, because whenever x is going to be greater than 1, it will have positive output. Okay. So for that, it will be greater than 0. And whenever it is lesser than, whenever it is in between 0 to 1 and lesser than 0, it is going to be negative. Okay. So for that, you can just see in 0 to 1, it is going to be negative. In 0 to 1, it is going to be negative. Clear? So if in between 0 to 1, if it is negative, and if it is positive, if it is greater than 1, then you can just say that it is going to be oscillating. It is going to be oscillating, because you just see here, they have mentioned x is greater than 0. They have mentioned x is greater than 0. From 0 to 1, from 0 to 1, you can just see this term becomes negative. From 0 to 1, this term becomes negative. And after 1, it becomes positive. Clear? So therefore, from whenever x is greater than 0, you just see from 0 to 1, it is negative. From 1 to positive infinity, it is positive. So therefore, from this, you can just say it oscillates. It oscillates whenever x is greater than 0. Whenever x is greater than 0. Okay. So see, very simple problem. Here, please don't get any doubts or any confusions. You have to understand it very carefully. They have mentioned that x is greater than 0. That means it goes towards positive infinity. So if we solve this, you are going to get this particular function. So for x, you can just see from 0 to 1. If I put any term here, this term becomes negative. This term becomes negative. If I put x is greater than 1, it becomes positive. Becomes positive. So from 0 to positive infinity, from 0 to positive infinity, it is oscillating. Is oscillating. Okay. So now quickly we can move to problem number 8 about monotonic function. Okay. F of x is stationary at x equal to a. F of x has extreme point at x equal to a. F of x is increasing or decreasing at x equal to a. None of this. So from the definition, you can just say that it is both either increasing or decreasing at x equal to a. Either it is increasing or decreasing at x equal to a. Clear? So therefore, from this, we can just see that f of x is increasing or decreasing whenever x equal to a. You can just see through the definition of monotonic function. That is, monotonic function means whenever f of x1 is greater than f of x2, x1 must be greater than x2. X1 must be greater than x2, so that we say that monotonically increasing. Monotonically increasing. And whenever we say f of x1 is lesser than f of x2 and x1 is lesser than x2, we say that it is decreasing. Monotonically decreasing. And whenever at x1 equal to x2, we say it is increasing or decreasing. Okay. That is option number 3 is going to be correct option for this problem number 8. Clear? Okay. Now let us go to problem number 9. F of x is decreasing at x equal to a, then f dash of x is greater than 0, f dash of a is lesser than 0, f dash of a is equal to 0, f dash of a is lesser than 0 need not always be true. So my dear students, here from the definitions we know that it need not always be true. Okay, for some particular functions, whenever f dash of x is greater than 0, it may be decreasing. Clear? So always it need not be true. Clear? Please remember this, because in theory we always study that if f dash of a is lesser than 0 at x equal to a is decreasing, but this is not sufficient condition, it is called necessary condition. Okay, it's not sufficient condition, it is necessary condition. So therefore you just remember that it need not be always true. Clear? Okay, so now we can move to the 10th problem. See, the 10th problem is, if f of x equal to kx minus sin x is monotonically increasing, then k value is what? So first we should differentiate it. So differentiation of kx, k is constant, differentiation of x is 1, k into 1 is k, differentiation of sin is cos, k minus cos x is greater than 0. K minus cos x is greater than 0. If k minus cos x is greater than 0, you can just see that k should be greater than cos x. If k is greater than cos x, and we know that cos x lies in between minus 1 to plus 1, so k should be greater than 1. K should be greater than 1. Okay. See that k should be greater than 1 because 1 is the maximum term. 1 is the maximum term of the cos x. So it should be the greater than the maximum term. Therefore, if k is greater than 1, then we can say that it is monotonically increasing function. Because f dash of x is greater than 0, then only it is increasing. If they ask decreasing, you should take f dash of x is lesser than 0. Then it is going to be k minus cos x is lesser than 0. You can take k cos x, k is lesser than cos x, and k should be lesser than 1. Okay, or decreasing. Clear? But here they have mentioned only increasing. That's why k must be greater than 1. K must be greater than 1 for the increasing functions. K must be greater than 1 for the increasing functions. Okay. We can go for 11th problem, that is the function f of x is equal to x by log x increasing on the interval 0 comma infinity, 0 comma e comma infinity, none of this. Now here the function f of x increases on the interval they are asking. Okay, so for that reason on the interval it is increasing means you just differentiate the function. By differentiating the function, what you are going to get? You will get log x minus 1 divided by log x whole square. So you just take f dash of x should be greater than 0. Therefore log x minus 1 must be greater than 0. If log x minus 1 is greater than 0, then log x should be greater than 1. And you can just see that here x is greater than e, means e comma infinity is going to be our answer. E comma infinity is going to be our answer. Okay. Clear? So now you can just understand this from our differentiation, that is log x minus 1 divided by log x whole square. Okay, so log x minus 1 greater than 0, x should be greater than 1. Therefore if you simplify it, be greater than e to the power of, okay, so here log x minus 1 is greater than 0. Therefore you can just see log x is going to be greater than 1, x is going to be greater than e to the power of 1. That means x will belongs to e comma infinity. X belongs to e comma infinity. Okay. Now we can move for problem number 12, that is a greater than 0, a lesser than 0, a is in between 0 to 1. And the fourth one is a is greater than 1. And you can just see f of x is given as a power x. If I differentiate it, all of you know that differentiation is a raised to x into log a. And according to the problem, f dash of x must be greater than 0. If f dash of x is greater than 0, then you can just see that a raised to x log a is greater than 0. So therefore, from this you can just see log a is greater than 0. That means you can just see that a should be greater than e to the power of 0. Therefore, a should be greater than 1. That you can see here, greater than 1. So if a is greater than 1, then that is your answer. Clear? Is option 4. Okay. So problems are very simple here, that you have to just know the concept. You must know the differentiation, and if you have the differential skills, if you know how to differentiate the given function, as well as if you know the techniques of increasing and decreasing function, easily you can solve this type of problems. Therefore, if a is greater than 1, then you can say that this particular function is going to be increasing. Okay. Now quickly we can go for problem number 13. See that the function f of x is equal to 2x square minus log x is a decreasing function, if x belongs to the interval given option 1, option 2, option 3 as well as option 4. Okay, so first we shall differentiate it. We are going to get 4x minus 1 by x. We are going to get 4x minus 1 by x. If you simplify it, it will be 4x square minus 1 greater than 0, because f dash of x should be greater than 0 for increasing. For decreasing, f of 4x square minus 1 must be lesser than 0. Okay, so here they have asked for decreasing function, so we take the second one, that is 4x square minus 1 should be lesser than 0. Therefore, x must be in between minus 1 by 2 to plus 1 by 2. Okay, so you just differentiate this, that will be 4x minus 1 by x, because differentiation of log x is 1 by x, differentiation of 2x square is 4x. So if I simplify, it will be 4x square minus 1 divided by x. Therefore, it should be lesser than 0. So 4x square minus 1 should be lesser than 0. 4x square should be lesser than 1. And you can just see that x should be greater than minus 1 by 2, lesser than plus 1 by 2. Okay. Therefore, problem number 13 gives you option 1 as the, option 2 as the right answer, because you have log x which is positive for only x is greater than 0. So for that, with this interval, you have to take x should be greater than 0. That's why option 2 will be the right answer, because this is not true for log x. This is not true for log x, because for log x, x should be greater than 0. Okay. So if x is greater than 0, we can say that the given function is possible. So therefore, it is possible only for 0, 1 by 2. It is possible for only 0, 1 by 2. Okay. So now we can go for problem number 14. And as you all know, you have to differentiate it and you have to check it is greater than 0 or not. And for what value of k it is greater than 0, then it is going to be increasing. Okay. See, if the function f of x is increasing for all values of x, then okay, so for that what we do, we just differentiate it and we get see k sin x plus 2 cos x divided by sin x plus cos x. From this you can take sin x common. So if I take sin x common, it will be or if you want to make it as tan, you can take cos x common. If I take cos x common, it will be k tan x plus 2 divided by 1 sin x by cos x is tan x plus 1. Okay, so here you have cos x will get cancelled. K tan x plus 2 divided by tan x plus 1 you are going to get. So if I differentiate it, it will be k minus 2 into secant square x divided by sin x plus cos x whole square. Okay, so f dash of x must be greater than 0. So if you want, you can just differentiate this by u by v rule, and you will get k minus 2 into secant square x divided by sin x plus cos x whole square by differentiating this. Okay, so from that you can just see k minus 2 must be greater than 0, k must be greater than 2, k must be greater than 2. Clear? Therefore option 4 is the correct answer. Option 4 is the correct answer. Clear? So for that you have to be very careful, as well as don't lose your concentrations while solving. Otherwise you can simplify AD minus BC must be greater than 0. So AD means A value is k, D value is 1, k minus 2 must be greater than 0, k must be greater than 2. Clear? So here if the function is positive, it is very good. If the function is negative, then you have to be again very careful about your function, and you have to differentiate it. You have to differentiate it and you have to solve. Okay. So now I think we have solved 14 problems. So if you have any doubt, once you can check, and you can also put your doubts in our chat box or WhatsApp chat box, as well as your YouTube chat box. You can just put any doubts if you have. Otherwise, no problem. We can just go through it and you can understand them. Problems are very simple, and you go through all the problems which I have solved, as well as you just note down the techniques what I am using. Techniques are very important. You just note down them, and you can take the notes of it. Clear? No problem. So let us go for problem number 15. So this is very straightforward question. That is, they are asking about the definition. Okay, so see this. Let I be an open interval contained in the domain of a real function f. Let I be the open interval contained in the domain of a real function f. Then f of x is called, strictly increasing function in I if x1 lesser than x2 in I, f of x1 is lesser than f of x2. x1 greater than x2 in I, f of x1 is lesser than f of x2. x1 equal to x2 implies f of x1 equal to x2. None of this. This is straightforward question from your definitions. You no need to solve anything. So from definition you would know that if x1 is lesser than x2, f of x1 must be lesser than f of x2 for increasing, and if f of x1 is greater than f of x2, f of x1 is lesser than f of x2, then it is decreasing, and here it is neither decreasing nor increasing. Okay, so now we can move to problem number 16. Okay, so see problem number 16. F of x is given as 2x cot inverse x log of root of 1 plus x square minus x. Option 1 is decreases on 0 comma infinity, decreases on minus infinity comma 0, neither increases nor decreases on minus infinity comma infinity, increases on minus infinity comma infinity. So here you can call it as real number set, here you can call it as real number set, and here you can call it as negative real numbers. Okay, and here you can call it as positive real numbers. Clear? So now from this we can move to differentiation of 2x plus cot inverse x plus log of root of 1 plus x square minus x. So f dash of x is 2. Differentiation of cot inverse x is 1 by 1 plus x square. Differentiation of log of root of 1 minus x square minus x is 1 by root of 1 plus x square minus x. And again the differentiation of root of 1 plus x square minus x will be 1 by 2 times of root of 1 plus x square into 2x minus 1 into 2x minus 1. Okay. So now you just simplify this so that you are going to get 2 minus 1 plus 1 by 1 plus x square plus 1 by root of 1 plus x square minus x minus root of 1 plus x square. This term and this term will get cancelled, and here minus sign will be common. Take negative common from this, that these two terms will exchange its places, because minus of root of 1 plus x square minus x. Therefore you can cancel these terms, minus will be outside, so that 2 minus 1 by 1 plus x square minus 1 by root of 1 plus x. From that you can just see it will be 2 times of 1 plus x square minus 1 minus root of 1 plus x square divided by 1 plus x square. Take LCM and simplify and you can just see this is always positive, always positive, always positive for any value of x, for any value of x. Okay, because x square is always positive if you give any x belongs to R. So for any x belongs to R, this is always positive. For any x belongs to R, this is also always positive. For any x belongs to R, this is also always positive. So for every x belongs to R, complete function is going to be greater than 0. Hence we can call it as x belongs to R will be our answer. That is option 4. That is our option 4. Okay. So quickly you can see once about your option 4. See, for all real numbers it is increasing. For all real numbers it is increasing. Clear? But you must be very careful regarding the differentiation and the techniques what you use to simplify your equation. Okay. So now from this we understand that option 4 is going to be the correct answer. Now we can quickly move for problem number 17. That is the function f of x. The function f of x is x into root of ax minus x square. X into root of ax minus x must be greater than 0. A must be greater than 0. So now you can just see this is u, this is v. If I differentiate it, you are going to get the differentiation term as 3ax minus 4x square divided by 2 times of root of ax minus x square. Multiply this term to 0, therefore it will be 3ax minus 4x square greater than 0. Therefore 3ax greater than 4x square. So from this you can just see, taking x as common, you can write it as, here take x cancel also, no problem. That is 3a is going to be greater than or equal to 4x. The same term you are going to have. 3a is going to be greater than 4x, so that will be 3a divided by 4 greater than x. That means x is lesser than 3a by 4, so therefore f dash of x must be greater than 0, and x belongs to 0 comma 3a by 4, 0 comma 3a by 4. Okay, because you just see here, if you get negative term for x, this term becomes negative and it comes for complex number. For that reason, you can just see it should be always positive. So therefore 0 comma 3a by 4 will be the right answer. 0 comma 3a by 4 will be the right answer. Okay. Okay. So quickly now see problem number 18. That is f of x equal to x minus e power x is decreasing in f of x equal to x minus e power x is decreasing in. Okay, so you differentiate it. You differentiate, we know that differentiation of x is 1 and differentiation of e raised to x is e raised to x, and for decreasing f dash of x must be lesser than 0. Take that term, therefore you can take 1 on this side, so that will be minus e raised to x lesser than minus 1, multiply negative on both sides, so you are going to get e raised to x greater than 1. Therefore e raised to x greater than 1 means you can just see x must be always greater than 0. X must be always greater than 0. So therefore 0 comma infinity will be our answer. Clear? Very simple problem. I think everyone can understand this. If you have any doubts, quickly you can just put me in the WhatsApp group, or privately you can just message me so that I can clarify your doubts. So now you can go through all your homework problems once and you can solve them. Clear? Okay, so you just say this f of x equal to root of x square minus x square minus a square is increasing on. So you just differentiate, x must be always greater than 0. Here x will be greater than 0 for any term, but here x must be always greater than 0. So therefore you can just see if x is lesser than minus a or if x is greater than a, and x belongs to a comma infinity. X belongs to a comma infinity. Clear? So from this you can see that option 1 is our right answer. Option 1 is our right answer. Okay. So for this, no problem, it can take any values and you have to simplify this, x square minus a square. So x minus a, x plus a should be greater than 0. If I simplify this separately, you can just see that x should be greater than a, x should be greater than minus a, x should be greater than a, and x should be greater than minus a. Therefore you just see that a belongs to, x belongs to a comma infinity, x belongs to a comma infinity. So therefore your option 1 is going to be the right answer. Clear? Okay, so we shall meet in the next class, that is tomorrow. So I will see, if possible I will put live class, otherwise I will go for the recorded classes. Okay. Okay. So quickly we can move for the second problem. that is root of a square plus x square, increasing on given 4 options. And first we differentiate it. So by differentiating, you can just see this is root of f of x. Root of f of x. What will be the formula? 1 by 2 times of root of f of x and multiplied with f dash of x. Therefore, this will be 1 by 2 times of root of a square plus x square into 2x. 2 will get cancelled. So, x divided by root of a square plus x square. X divided by root of a square plus x square. 2 will get cancelled. X divided by root of a square plus x square should be greater than 0. Therefore, x is greater than 0. For x greater than 0, we can say the function is increasing. Is 0 comma infinity. 0 comma infinity. Clear? Okay. So already we have discussed this, that is AD minus BC must be greater than 0. So therefore, for f dash of x, we know that AD minus BC must be greater than 0. Then only we can say that this function is increasing. Clear? Because by differentiating this function, we are going to get AD minus BC divided by CX plus D whole square. And here Cx plus D whole square is always greater than 0. This is always, okay. Now you can just see that AD minus BC, if it is greater than 0, if it is greater than 0, then the function is increasing. Then the function is increasing. Clear? Okay. So we can meet in the next class. Okay. Thank you everyone.